Right. So students, we've already seen the concept of molarity, isn't it? Yes, we've learned the formula and how to go about with that. We've already seen. So let us start solving important numericals of molarity. Basically, your molarity concept, finding a concentration, n number of numericals which are related to this concept, and we'll be doing one after the other, both your NCERT questions as well as your comprehensive questions. Fine. So let us read the first question. So when I have to go with the first question, let us see what did they give us. Calculate the mass of sodium acetate, that is a formula given to us here, required to 500 ml. Okay, required to 500 ml. Like this is a small word missing, isn't it? So let us read again. Calculate the mass of sodium acetate required to make this. There should be a word here, make. Okay, make 500 ml of 0.375 molar aqueous solution. Molar mass of acetic acid, sodium acetate is 83.02 gram per mole. So basically, what did they ask me? They asked me to calculate the mass. Fine. So for such things, first of all, when they have given you such data, try to first note what is given to you. So what should you find out? I need to find mass, right? So what else is given to you? They've given you the molar mass of solute, isn't it? See here, this one. They've given you molar mass of solute. Molar mass of solute. How much is given to you? Solute is nothing but sodium acetate. It is given 82.0245 gram per mole. Okay, right? Gram mole inverse or gram per mole. Done. What else is given? Volume is given to you. Volume, how much is given? Volume of what? Volume of solution is given to you. Volume of solution is equal to 500 ml is given to you. Done. Fine. So I should find mass of solute, isn't it? This is nothing but mass of solute. So let us come back and write the formula. Fine. So anything else is given? They've also given molarity. See here, calculate the mass of this one. So of 0.375 molar aqueous solution. Molar aqueous solution is nothing but molarity. Molar aqueous solution means molarity, that is 0.375 molar, capital M. Right. So let us write the formula first. According to the formula, molarity is equal to W into mass of the solute, isn't it? That's mass of the solute by the volume of the solution in liters, isn't it? So what is that? Mass of the solute can be written as weight by molecular weight, right? Then small m, let us write this into volume of the solution. So volume of solution. Fine. So this solution is in ml, and now weight by molecular weight into 1000. Right? So fine. So now substitute the values. Now what do we need? We require this mass, isn't it? So what do we require? We require the weight. This weight. Molar mass is already given. So I require this weight. W I require. So when I take this mass of the solute, fine. So when I take this W out, I'm getting this W out. I'm cross multiplying molarity with this. Okay. This W out and this molarity out. Fine. W is equal to, molarity is how much? Molarity is nothing but 0.375. This is the mass which they've asked, and after that into how much is the molar mass given to us? It is nothing but 82.0245 into what is the volume of the solution given? 500 ml. 500 ml divided by, yes, 1000, isn't it? This goes down 1000. So how much do I get? I'm going to get an answer of 15.379 grams. That is nothing but, if I approximate this, because the significant number is more than 5, this becomes 15.38 grams. That's it. This is your first numerical. Hope this is clear to you all. Fine. So let us see the next question in molarity. So here in the next question, what do they give us? Right, let's read. Calculate the concentration of nitric acid in moles per liter. Okay, in moles per liter. Fine. This is the same sentence which is repeated, in moles per liter, in which one? In a sample which has density of 1.41 gram per milliliter, and the mass percentage of nitric acid in it being 69%. Fine. So let me first write what is given to us. So in the given data, yes, what's given? Density is given 1.41 gram per milliliter. Right, then what did they give us? What should I calculate? I need to calculate the concentration of nitric acid in moles per liter. So concentration of nitric acid in moles per liter means, what does that mean? Right, basically they are asking us they're asking us to find the concentration of nitric acid, like means they've given the units, right? They're asking us to find the molarity only, nothing else. Fine. Moles per liter unit is nothing but for molarity, isn't it? Fine. So that is what they're asking us. Fine. That's okay. Now I need to find capital M. Then after that, is there anything else given? They've given us mass percentage also. See here, mass percent of nitric acid is being given 69%. So mass percentage, what does it mean? That means 69% HNO3, right, means 100 grams of solution. What does this mean? 100 grams of this one contains what does it contain? It contains 69 grams of HNO3. This is what it means. Fine. So what is mass of HNO3 now? Yes, so mass is equal to 69 grams. Okay, fine. So let us find the molar mass. I need to find molar mass because of molarity formula. I need molar mass also. So molar mass for HNO3, molar mass of HNO3. How do I calculate this? I calculate molar mass. First mass of hydrogen is 1.0079 plus what is the mass of nitrogen? 14 plus 3 into 16. How much do I get? I come to 63.01 gram per mole. Okay, I got molar mass. So everything. Now let's come back. What is the formula for molarity? Molarity is equal to moles of the solute. That's the mass of the solute, isn't it? Right? That mass is equal to weight by molecular weight into 1000 by volume of the solution, right? Isn't it? Yes. So did they give us anything? They've given volume. They've not given us volume. They've given us density. So calculate density is equal to mass by volume. Let us write this as step 1. Let us write this as step 2. Density is equal to mass by volume. So cross multiply this volume. Volume is equal to mass by density. How much do we get? What is the mass given? 100 grams, isn't it? 100 grams divided by how much is the density given? 1.41. So how much will this come up to? Okay, we can directly leave that and calculate. Fine. So now substitute volume. Now substitute what is the weight of this one which they've given? Nitric acid, because this is for the solute, isn't it? This is for the solute. This is for the solution, isn't it? Fine. So weight of solute, how much did I write? 69 into 1000 divided by what is the mass? This one. Okay, 63 grams, which we have got 63.01 into what is a volume? It is, volume is 100 grams. 100% means 100 grams, isn't it? 100. Okay, so here we have already got this volume 100 into, this is already there, into 1.41, because volume is 100 by 41. When it goes, it becomes the reverse. When I solve this, I get an answer of 15.43 molar. This is what is the answer, right? Hope this is clear to you all. This is how you're going to do. First, see what data is given to you all and see what to calculate, and after that write the formula and substitute in the formula. Right. Now let's come back and do the next sum, which is related to your molarity. So we have seen 2 combinations. Now let's see the next one. So in this question, what did they give us? Here again, they've asked us, this is, as I said, all these are molarity numericals. Let us read the question first. What is the concentration of sugar, that is your C12H22O11, in mole per liter? Fine. If it's 20 grams are dissolved in enough water to make a final volume of up to 2 liters. Right. So first of all, they are asking us to find concentration of sugar. So the concentration, what we are speaking concentration in terms of molarity here, isn't it? Yes. So I need to find the concentration, of this particular thing. Simple. It's a direct question rather, if I have to say. First of all, so when I have to find the molarity concept, first of all, let us write the formula. So molarity is equal to weight by your molecular weight into volume in liters. This is what is your formula, isn't it? Now let us write the data which is given. So let us write given data and substituting the formula. When I have to see, first of all, what do we require? Do we have weight here? Yes, W is given to us 20 grams. W is equal to 20 grams is given to us. Did they give us your mass or volume? Okay, volume, we'll see. Volume is given to us enough water to make up the final volume to 2 liters. Okay, they've given us volume as 2 liters. Already this is in liters, this is also in liters, not a problem. And after that, did they give us molecular molecular mass. Okay, molecular mass. This mass is not given to us. That mass I'm going to calculate for C12H22O11. How much is this? C12H22, it's nothing but 12 into the mass of carbon, right? Fine, 12.01 rather, plus 22 into 1.007 of hydrogen, plus 11 into 16 of oxygen. Total this comes to 342 gram per mole. Okay, all are ready. I can directly substitute in this, isn't it? Yes, let's substitute. How much is the weight? 20. How much is the mass given to us? Your calculated mass. It is 342 into 2, because everything is in liter. So when I calculate this, when I solve this, I get an answer of 0.02092. Fine. So here, what are the units? The mass is in gram per mole, isn't it? Yes, weight and this and gram per mole and gram per mole. This is also in grams. This is gram per mole. Fine. So this grams and this grams gets cancelled. So what are we left with? Only mole. Mole per liter. So what are the units here? Mole per liter. This gram and this gram gets cancelled. This is already mole, this is already liter. When this goes above, this becomes mole per liter. Fine. So this is your answer. So finally, how can you write this? 0.0292 molar solution. This is what is. This is how you're going to explain. Hope this is clear to you all. Yes, let us come back and see the next question. Fine. So here in the next question, this again, as I said, we'll be doing one more molarity numerical. All these are molarity numericals, different variations of molarity numericals. Right, now let's start solving this numerical. First of all, let's calculate the mass percentage. Fine. So percent by mass and mass percentage, both are the same. When I have to do the first part, let us just solve the first part and see. Explain this mass percentage. What actually is mass percentage or percent by mass? Mass of the solute by mass of the solution into 100. That is what is mass percent. But here, what did they give us? They've given us 15 ppm. They've given this. This is what is given. Contamination by 15 ppm by mass. That is why I'm picking up this concept. So 15 ppm is nothing but 15 parts. 15 parts in 1 million. That is 10 raised to 6 parts. This is what is 15 ppm means. Right? So let us write. Now percent mass. Percent by mass. When I have to calculate. Yes. So mass of the solution they've given here in terms of 15 ppm means I've already written this. Pick that thing here. 15 okay into 100 is already there because it is a percentage divided by 10 raised to 6. So how much do I get when I solve? I get here an answer of 1.5 into 10 raised to -3 percentage. This is your ppm. Fine. Let's come back and do the next one. Determine the molarity of chloroform in water sample. So when I have to determine the molarity, yes, so let us do the second part. So molarity, what is the formula? Weight by molecular weight into 1000 by your by volume into volume of sample. Okay, volume of sample. So what data is given to us here when I have to see? Fine. So let us see whether weight is given to us, right? So they've given here basically a sample of drinking water here in this particular question. They have written like they've given sample of drinking water was found to be contaminated, carcinogenic. Only mass is given, nothing else is given to us. Fine. Okay. So now I can easily start with this numerical. Why? What am I trying to tell you? They said contamination in water. That means, fine. So here your already mass we have got, isn't it? What is the mass? That is your mass percentage. This molarity, that mass I can directly substitute into 10 raised to -3. This 1000 is also there divided by, yes. This one, what is the molar mass of this? Molar mass of which one? They said chloroform contamination. They said, fine. So chloroform contamination means I can easily find, isn't it? So CHCl3, how much is this? Carbon comes to 12 plus hydrogen is 10079. How much is chlorine? 3 into 35.5. Okay, when I solve this chloroform, I get an answer of 119 gram per mole. Okay, this is what is your weight. So substitute that value 119 gram per mole, that is your 119 into volume of the sample is 100. 100 ml, because they've given parts per million, that the thing they've given, isn't it? So into 100, done. Fine. So why did I take this? Because 1.5 into 10 raised to the power of -3. 1.5 10 raised to the power of -3 means 1.5 10 raised to the power of -3 grams are present in 100 grams of sample. That is what is that? Parts per million is that only, right? So that is why I've taken 100 here, right? When I solve this molarity, I get an answer of 0.000126. Further, when if I have to write, molarity is equal to 1.26 into 10 raised to the power of -4. Hope this is clear to you all. They've given parts per million. First, you need to convert the parts per million. This is nothing but, as I said, it is 1.5 into 10 raised to the power of -3 percentage. It's nothing but, when you write in grams, 1.5 into 10 raised to the power of -3 grams present in 100 grams. This is present in 100 grams. That the same concept I've applied there also, right? So let us do the next numerical, which is based on molarity. Fine. So here there's one reaction given to you all. Basically, these are all comprehensive numericals. Let's do reaction 2Br minus aqueous plus Cl2. Aqueous gives 2Cl minus plus Br2. Okay, is used for commercial preparation of bromine from its salts. Okay, if we have 50 ml of 0.060 molar solution of NaBr, what volume of 0.050 molar solution of chlorine is needed to react completely with Br minus ions? Okay, fine. So basically, they've given us a lot of information here. They've given us your M1, they've given us like your V1, they've given us M2. I need to find V2. Okay, let us write what actually are this. Fine. So first of all, when such question is given to you, write the formula which you're going to use. How did I know that it is M1, V1? Basically, they've given different molarities, isn't it? Here molarities are given, volume is given. They're asking us to find the other volume. So that is the reason I could predict that formula. Fine. So first of all, let us take the formula. M1 V1 is equal to M2 V2. Right, but here they've given one question here, reaction here, isn't it? Suppose if I assume, let us take this M1 V1 in terms of your Br, because it is the stoichiometric equation is 2, isn't it? So I'm taking this as 2. Let us take your M2 V2 in terms of chlorine. Okay, right. So here chlorine, how much is chlorine? It is only 1, isn't it? So 1. So take this relation in this way and see. Fine. Now let us write what information is given. Here they've given us M1 is equal to 0.060. This one, this M1. Fine. How much? What is V1? V1, I need, okay, V1, how much did they give you? 50 ml of 0.061. So V1 is 50 ml. How much is M2 given? M2 given is 0.050 mole liter inverse. Okay, so M1 also mole, the same thing, 0.06 mole. Molarity is nothing but mole per liter inverse only, Yes. So V2 is how much? I need to find. So let us come back and substitute in this formula. So take these values. V2 is equal to, now cross multiply this. What do you get when you cross multiply this whole thing? It becomes a reverse order, isn't it? So V2 becomes M1 V1 by 2 into 1 by M2. Correct? Yes. So substitute the values now. V2 is equal to, M1 is how much? 0.060 into how much is V1? 50 divided by 2 into how much is M2 here is 0.050. So finally V2, how much do I get? When I solve, I get volume of 30 ml. This is your answer. This is how you're going to do the sum. So hope this concept is clear to you all. I'm gradually doing all the varieties of numericals which you should be practicing for molarity. More than this you will not be questioned. So try to practice all the types of molarity numericals at one stretch. Yes? Yeah. So let's come back and see the next variety question. Here they've given us molarity and normality. Both the concepts are linked here in this case. So let's read the question. How much volume of decamolar solution of sulfuric acid is required to prepare 500 ml of solution with density 1.03 gram per liter and having mass percentage equal to 40%? Fine. Also calculate the molarity and normality of the resultant solution. Fine. So here I need to find both molarity and normality. So first of all, you should know the formulas of these two. Then only you will be able to do the sum. Fine. So first of all, molarity. Fine. Normality, molarity, both the formulas will write. But here you should one thing remember. They've given a density. I've taken one class where I said relation between molarity and density. There's one formula also directly given. I'll write that formula first so that I can easily apply. So for molarity, there's one formula as I said just now. Molarity in relation with density. What is that? Molarity is equal to percentage into 10 into d by molarity of the given sulfuric acid. Fine. So the second one, when I have to speak about normality formula is molarity into molecular mass divided by equivalent mass. This is one more formula. Now let's substitute here. In this case, what do they give me? What is the percentage of this one given mass equal to 40%? They given 40 into 10. How much is the density given? Direct substitution. 1.03, right? How much is the molar mass of sulfuric acid? This is for sulfuric acid, isn't it? We're speaking in terms of sulfuric acid. Sulfuric acid molar mass is 98, isn't it? So how did I calculate sulfuric acid? Like that. So 2 into 1 plus 32 is the molar mass of sulfur plus 4 into 16. I got 98 gram per mole. This is okay. Yes. Now substitute the value here. You get 98 gram per mole. When you divide this whole thing, you get an answer of 4.20 mole per liter. Okay. This is over. The molarity value you've got. Fine. So now one more thing. What did they say? Okay, volume of decamolar. They said how much volume of decamolar solution they said. Fine. So volume of decamolar. So decamolar is nothing but 10 moles, isn't it? 10 molar sulfuric acid B. Right. So then what can I write? So that decamolar, if I take volume into 10. So how much is the volume given to us? They've given 4.2. Isn't it? Yes. So I've got means the volume which I've got that particular thing volume into 10. That means what am I trying to explain? I'll show it in a subject. What am I trying to explain is let the volume of decamolar is nothing but 10 molar. Okay, deca means 10, isn't it? Decamolar sulfuric acid solution, okay, required B, that will be VML. Fine. That means V into 10 is equal to 4.2 into 500, isn't it? Okay. So why am I finding? I need to substitute this value in my normality also, isn't it? Right. So V is equal to 4.2 into 500 divided by 10. How much do I get? I get an answer of 210 ml. Okay. Now, second, because I need to find for this one, isn't it? Equivalent mass. Equivalent mass, nothing but your basicity by your this one, the basic, but divided by the mass divided by the molar mass divided by the basicity, isn't it? Yes. So that's why I'm trying to find this value. So 210 ml I've got. Now, what is basicity? Now basicity of sulfuric acid, H2SO4 is 2, isn't it? Yes, 2 ionizable ions. Fine. So now equivalent mass you calculate. Equivalent mass of sulfuric acid is equal to molar mass divided by basicity. It comes to 49. Now it's easy for me to substitute. Normality is equal to molarity into molar mass divided by equivalent mass. Now what is molarity? I got 4.2. What is the molar mass of sulfuric acid? 98. What is the equivalent weight? Which I got 49. So when I calculate, I get an answer of 8.4 normality. This is how you are going to do the sum. This is directly molarity in relation with density is one numerical. Next one is a normality. Fine. Hope this is clear. Let us come back and do one more sum. Keep noting it, and you keep solving the numericals. When you start solving more number of numericals, your concepts will be clear. Yes. So let's do this. Next question. Commercially available concentrated HCl contains 38% of HCl by mass. Okay. What is the molarity of this solution? Density again is given. Same variety of question. What volume of concentrated HCl is required to make 1 liter of 0.1 molar HCl? Okay. Fine. So in this question, what should you do? You need to find the molarity, and you should also need to find the volume, isn't it? Yes. So let us do step by step. So first of all, molarity, as I said, when density is given, what formula can you apply for molarity? Molarity is equal to percentage into density into 10 divided by molar mass. This is one formula which you can apply. Fine. So let us see. Now in this case, percentage, how much they give me? They've given 38%. So right now 38. How much is the density given to us? It is 1.10 into 10 divided by what is the molar mass? Molar mass of what? Of HCl, isn't it? HCl is nothing but 36.5. How did I get this? Hydrogen is 1 plus chlorine is 35.5. So this comes to 36.5. I have got this. So how much is the answer? When you divide this, you get molarity is equal to 11.45 mole per liter. This is over, isn't it? Okay, now done. Now I need to find the volume. First part is over. Second part I'll do it. What volume of HCl, concentrated HCl is required? So when I've asked us to find the volume, right? So in the second concept, we have molarity equation, isn't it? So let us write according to molarity equation. What is molarity equation? Molarity equation is M1V1 is equal to M2V2. Now M1V1 will take it for concentrated HCl. M2V2 will take it for dilute HCl. Okay. Yes. So what do we require? They've asked us to find what? They've asked us to find what volume of concentrated HCl I require. So they're asking us to find out what volume I need to find. So okay, sorry, what I need to find this volume. So when I take out this and substitute the leftover values, I get an answer. This one as 0.1 into 1.0 by 11.45. So this comes back to 8.73 into 10 raised to minus 3 liter. If I have to convert in milliliter, 8.73 milliliter. That's it. This is your volume of concentrated HCl V1. This is how you're going to do this. Yes. Hope this is clear. Concept is clear. I'm trying to do all types of numericals. Please try to practice it. Fine. Let's come back to one more question. So in the next question, yes, a sample of sodium hydroxide weighing 38 grams is dissolved in water and the solution is made to 50 ml in a volumetric flask. Okay, what is the molarity of the resulting solution? Fine. How many moles of sodium hydroxide are contained in 27 ml? Okay, so in this particular question, fine. What did they give me? What should I find out? I need to find out first of all molarity also. Then I need to find out how many moles also. So both the concepts are given to you. Right? We'll do step by step. First of all, moles of sodium hydroxide. Let us do that and then come back. Moles of sodium hydroxide in 50 ml. Okay. Because I'm from the known, we are going to the unknown. In that way, we'll go. So let's see. I have to solve this. Moles of sodium hydroxide in 50 ml. What is this? What is mole? Mole is nothing but weight by molecular weight. Weight of sodium hydroxide by molecular weight of sodium hydroxide in grams. So weight of sodium hydroxide is how much? 38 grams. That given, isn't it? See here. A sample of sodium hydroxide weighing 38 grams. So 38 grams divided by molecular weight of sodium hydroxide is 40 gram per mole. This is also over. These two are over. So this is your number of moles. So when I what did they ask us? Now moles of 1 liter of solution, because how many moles are contained in this, isn't it? Okay, now when I have to take now moles of sodium hydroxide in 1 liter solution, the same thing. Let us find. moles of, therefore moles of NaOH in 1 liter solution, right? Fine. So 27, there's some information also missing, isn't it? 27 ml of 0.15 molar solution. Okay, this is important. Okay, I've left this data. Okay, so now substitute. This is there in 50 ml. So the 1 liter, if you find 38 by 40 into 1000 by 50. This is for 1 liter, isn't it now? Yes. So how much this come to? 19 mole per liter. Done. So now this is over. Fine. So now I need to find for this, the second, this one, they have given 0.5 molar. So we have got one answer for 1 liter. Okay, 1 liter, we have found this coefficient. Now we'll see for 27 ml. Right, let's see what am I trying to tell you. 1 liter of solution. Now they said, now why standardize this to 1 liter? The second concept is, they said, according to the second one, 1 liter of solution, which one of sodium hydroxide, NaOH, contains 0.15 moles. Okay, so 27 ml rather. 27 ml of solution contains how much? Isn't it? How much? So cross multiply 0.15 into 27 by 1 liter means 1000 ml. This is equal to 4.05 into 10 raised to minus 3 moles. Okay, this is how you're going to do. So start from your known factor, and then come back to the thing which you need to find out. Yes, so this is over. So let's come back and see the next question.